Today, let's talk about 30, 60, 90 triangle and how their side have some special ratios that's very useful if you have them memorized. And these pop up a lot, not just in standardized tests and in school, but also in competition mathematics tests, such as American Mathematics Competition and AMY and other competition math tests. So 30, 60, 90 triangle and 45, 45, 90 triangle. I'm going to make a separate video on 45, 45, 90. These two triangles you have to know. You have to know how their side ratios relate to their angles, if this side is x, this side is 2 times x, and this side is x times square root of 3. And in this video, we're going to talk about how to prove this, how to come up with these side ratios, and we are going to attempt to maybe work on one question that involves it. So let's begin. So 30, 60, 90 triangle can be obtained when you have an equilateral triangle which has 3 equal sides and 3 equal angles. So 60 degrees, 60 degrees, and 60 degrees, because all of them has to add up to 180. And you are basically splitting them up by drawing a perpendicular segment like this. So this angle now becomes half of 60 or 30, and this angle is 90. So you have 30, 60, 90 triangle that's forming. And the important thing to realize is that if you let this side be x, this side is also going to be x, because these two triangles, the triangle on the left and triangle on the right, are congruent. And you may say, why are they congruent? And let me prove it to you really fast. You know these two angles are the same, 60 degrees and 60 degrees, and you know this side has to be the same, and you know it's 90 degrees, and you have a hypotenuse that's the same. So by hypotenuse leg, you have the hypotenuse that's the same. You have a leg that's the same, 90-degree triangle. You can also use AAS. You can also use these two angles and one extra side. No matter how you do it, you do get the triangle congruency. In our case, I used hypotenuse leg to prove the congruency. So if this side is x, this side is also x, and this side is 30 and this side is 30. So we have the entire base of the equilateral triangle, the entire side length being 2x. So since all 3 sides of equilateral triangle have the same length, this side of the 30, 60, 90 triangle has to have the length of 2x. So let me redraw this 30, 60, 90 triangle. So I'm just drawing this red triangle right here. So you have x right here and you have 2x, and we wish to find the length of this side, and let's let the length of this side be a. And by Pythagorean theorem that a squared plus x squared has to be equal to 2x squared, and squaring 2x gets you 4, 2 squared is 4, and squaring x gets you x squared. And rearranging this, subtracting x squared gets us a squared is equal to 3x squared, and we want to find a, so you're going to take the square root of both sides, so plus or minus square root of 3, and taking square root of x squared gets you x. And since side length a has to be positive, you can disregard this negative sign, so you have a being equal to x times square root of 3. So we have it. We have our 30, 60, 90 triangle, and if the side length of this side, the smallest side opposite the 30-degree angle, so this is opposite the 30-degree angle, is x, then the hypotenuse is going to be 2 times x, and the side opposite the 60-degree angle is going to be x times square root of 3. So let's try out a question. So let's say you have a 30, 60, 90 triangle. That's 30 degrees, and the 60 degrees, that's 90. And let's call this 5. And you want to find the side length of the hypotenuse and the leg opposite the 60 degrees. Where the hypotenuse is going to be twice what the smallest is going to be, 2 times x, where the smallest is x. So in our case, it's going to be 10, 5 times 2. And the one opposite the 60 degrees, as we've seen, is going to be square root of 3 times x. So in this case, it's going to be 5 times square root of 3. So knowing the ratios for 30, 60, 90 triangle allows you to make this computation very quickly. Whenever you have 30, 60, 90, you can, and you know one of the sides, you can relate the opposite, the hypotenuse and the another leg based on the length of that side. And that can be very important problem solving tool to have.